AI agent evaluation got real for me on a billing automation that proudly stopped after calling the send email endpoint. Logs were green. The model wrote, "Invoice sent." Support found the customer never received it. The message was in a provider queue, then bounced because the attachment was too large. The loop had certified an action, not an outcome. Nobody checked the sent folder, the bounce event, or the customer record. That one false stop cost more human cleanup than the automation saved that week. Loops are good at continuing because the next step is usually visible. Search again, edit again, call another tool. Finishing is harder because done is a claim about the outside world. Naive agents stop when the plan is exhausted, when a tool returns 200, or when the generated text sounds confident. None of those are acceptance criteria. Worse, token and time budgets create accidental stops that look like completion if you do not label them. In production, the expensive failures are not always wild outputs. They are quiet, plausible, almost done states that enter your system as done. The pattern is a stop certificate. Before any loop terminates, it must produce one of three terminal certificates: success, blocked, or futility. Success means every acceptance criterion has evidence. Blocked means the loop cannot proceed without a missing permission, input, dependency, or decision. Futility means the loop has enough permission to continue, but further attempts are unlikely to change the result under the current budget and strategy. Anything else is continue. Opinionated rule: the worker does not certify its own work. It can propose a certificate, but a verifier, a separate model pass, deterministic checks, or a human gate approves it. Mechanically, start with an evidence matrix. Each acceptance criterion points to required proof. Not vibes, proof. Then evaluate the latest state against that matrix. Third, run a negative check. What would fake completion look like here, and did we rule it out? Fourth, choose status. In code, I often sketch an evaluate stop function that returns a small data class: status, evidence, missing evidence, blocked reason, futility reason, and next action. The important part is not the language. The important part is that a stop decision is structured data, auditable later, and separate from the worker transcript. Take a support reply agent. The task is not to write a nice apology. The task is customer received a correct reply and the case record reflects it. The evidence matrix has 4 rows. Criterion 1. Answer references the right order number. Proof is order ID match against the customer record. Criterion 2. Email was sent. Proof is provider message ID and sent state. Criterion 3. Delivery did not immediately fail. Proof is no bounce event after a short wait or webhook check. Criterion 4. Case updated. Proof is ticket status and node ID. A 200 response from sendmail is evidence for 1 row, not the whole certificate. This pattern still has limits. Your proof can be weak. A database row may show sent while the downstream service is delayed. Your verifier can drift if it uses the same assumptions as the worker. Some evidence arrives late, so you need pending states or delayed verification instead of pretending certainty, and every check costs latency and money. Do not certify everything like a bank transfer. Match rigor to risk. But be explicit. A cheap certificate with known gaps is better than a magical stop rule nobody can debug. The biggest failure mode is forgetting that absence of errors is not proof of success. Stop certificates sit between task specification and orchestration. If your task has no acceptance criteria, the certificate has nothing to check. If your retry policy does not read certificate status, it will retry blocked work and waste budget. If your observability does not store the certificate, you cannot later distinguish success from exhaustion. This also connects to state design. Certificates should reference durable evidence, not just chat memory. In the patterns tier, this is one of the core moves. Convert an agent judgment into a small protocol that other parts of the system can trust or challenge. Here is the 10-minute exercise. Pick one automation you already run or want to build. Write 3 acceptance criteria in outcome language. Not called API. Not drafted message. Outcome language. For each criterion, write the required proof and where it comes from. Then add 1 negative check per row. What would fake completion look like? A queued email, a cached page, a test file, the wrong account, a partial upload. Finally, decide who verifies. If the same worker can both perform and certify, add a separate verification step before you call the loop finished. 3 beats to keep. First, done is a claim, not a feeling, and not the end of a plan. Second, Use a stop certificate with success, blocked, and futility, backed by an evidence matrix where every criterion has proof. Third, rule out the most likely fake completions, and do not let the worker certify its own work. That is how AI agent evaluation becomes operational, instead of decorative. Tomorrow we keep building the Loop Toolbox. New Loop engineering episode daily on this channel. Practical patterns for agents that finish, verify, and stop.